morning, everyone. The following are some of the ground rules we've set up for this webinar. Well, first of all, I want to thank the New Jersey Society of Professional Engineers for having us this morning to be able to present to you the Goethals Bridge Replacement Project from a quality assurance and construction engineering point of view. As John has just stated, you can use the chat feature to type in any questions during the presentation, and we're going to hold responding to those questions until after the presentation. Also, you should press the Zoom button so you can show the small active speaker view. Following the Q&A at the end of the presentation or the assessment of learning, you will get a link for the completion and submission of your required survey prior to processing your PDH certification. And if I'm not mistaken, this part of the presentation is eligible for 2 PDHs or 2 professional development hours. The speakers that you're going to be here from this morning is first myself, James Adams, who's the Vice President and Field Project Manager for Construction Services for KS Engineers. I was responsible for managing all of KS construction engineering and inspection and quality assurance for the Goethals Bridge Replacement Project. I'm a licensed professional engineer in the state of New Jersey with more than 30 years of construction engineering, project management, managing projects of varying complexity and size. The second speaker that you're going to hear this morning is Rasul Sheikh Attar. We call him Rasul. Rasul was the senior project engineer on this project. He's a licensed professional engineer in the states of New York, New Jersey, LA, and Florida, and has extensive experience in construction inspection, supervision on a variety of bridge and roadway rehabilitation and construction projects in both New York and New Jersey. Rasul was responsible for the overall coordination among the senior engineers, successfully implementing the inspection and quality assurance programs and managing and administering the scope of services and the ethical conduct of our construction engineering and inspection effort. He oversaw correspondence to the developer and the lead contractor. He developed policies, methods, practices, and procedures to ensure conformance with the scope of work as stated in our scope of services. He regularly reviewed policies, assembled and managed his construction administration, inspection. He also ensured the complete documentation and correspondence regarding the work. And he represented the CEI, or the construction engineering inspection firm, in the performance of review meetings with the authority and the developer. And last but not least, our senior structural field engineer, Scott Plant, who has over 25 years of experience as a resident engineer for many local transportation agencies throughout the area, including Port Authority, New York DOT, New York State DOT, MTA, and many others. Scott is a licensed professional engineer in the states of New Jersey and New York. And as the senior structural field engineer, he was responsible for implementing quality assurance scope of services for all of the above ground work in accordance with the approved construction quality management plan, which I'll talk about a little bit later, including all inspections, testing, and reports. What you see now is just a brief outline of our presentation. The first part of the presentation will be covered by myself. Then, as I said, you'll hear from Rasul, then Scott, and then finally at the end, I'll come back for some questions and answers. As you can see, the outline starts with a brief introduction. We go into the history, the whys. We give you a little bit of our roles and responsibilities, which is key and important to the success of this project. We talk about our quality assurance plan, our org chart, and the overall org chart. Then we go into what we consider the meat of the presentation, the details, the challenges, the things that we had to face in order to make this successful construction project, including the foundation, the superstructure, replacement, demolition and replacement of the Travis Spur Bridge, some of the unique monitoring systems, the towers, and of course the stay cables, which is the unique feature of this once-in-a-lifetime project. What we're going to be presenting to you is the Goethals Bridge Replacement Project from the quality assurance and construction engineering and inspection point of view. The reason I emphasize that is the Port Authority, Parsons Transportation Group, which was the designer, KWM, Kiewit, Weeks, Massman, have all made previous presentations on the Goethals Bridge at numerous times throughout the lifespan of the project. But our presentation is unique in the fact that we're giving it from our point of view. Then, like I said, we'll go through the P3, the roles, responsibilities, org chart, and importantly, the difference between quality assurance and quality control. For those of you who are not familiar, just to go over a brief history of the Goethals Bridge. The Goethals Bridge spans the Arthur Kill, which links Elizabeth, New Jersey, with Holland Hook over in Staten Island. It was one of the first facilities that was constructed by the Port Authority of New York and New Jersey, and it was opened on June 29th, 1928, which just so happens to be the same day that the outer bridge crossing was opened. The Goethals Bridge was named in memory of Major General George W. Goethals, who was the builder of the Panama Canal, and he's also one of the first consulting engineers for the Port Authority of New York and New Jersey. And the Goethals Bridge is one of 3 Staten Island bridges that links New York and New Jersey. So why was the Goethals Bridge replaced? Why did the Port Authority have to spend untold millions or billions of dollars in order to replace the bridge? Number one, as I had said before, the Goethals Bridge was constructed in 1928, and at the time it met all design standards of the time and all design criteria. Unfortunately, the bridge has 10-foot wide narrow lanes, which are substandard as compared to the 12-foot wide lanes of today, no shoulders, and only 2 lanes of traffic in each direction, which during peak hours of travel in the mornings and the evening cause severe traffic backups. And if you ever remember traveling over the Goethals Bridge when there's a large truck next to you, you felt like you were taking your life into your own hands. Also, there was no access for pedestrians or bicycles. And like I'd said previously, the bridge had been deemed functionally obsolete, which means if the bridge was not replaced, the Port Authority could have ended up spending hundreds of millions of dollars on rehabbing the bridge, and it would still have remained functionally obsolete. Now, some of the constraints that the Port Authority and the team, the design and construction team, had to overcome was obviously the bridge has to span the navigational channel. And there was a minimum clearance from the top of the water to the bottom of the bridge of approximately 135 feet. But to the north was Newark Liberty International Airport. So the structure had a maximum height because it did not want to interfere with planes landing at Newark Airport. It was also had to be designed in such a way to enable future mass transit. There was a 4% maximum grade, and the bridge had to be designed to be able to provide a 16.5-foot clearance over the New Jersey Turnpike to the west, and it also had to come down to the east for the New York Toll Plaza. So there were many constraints that the design team had to take into effect when he started designing the bridge. The Port Authority, for one of the first times in its history, had chosen to use the public-private partnership in constructing, in designing and constructing and maintaining the Goethals Bridge. Some of the benefits to the Port Authority were they maintained their control of asset and revenue stream, and in other words, they kept the tolls. They had access to private enterprise or private sector expertise and capital. It minimized their strike to their bonding capacity. They had cost predictability over the life of the contract. And what was unique to this project and the Port Authority, the developer maintains the bridge for a 35-year maintenance period. Then they turn the asset back over to the Port Authority. Now, because of this unique arrangement, and one of the first times it's been done for the Port Authority, it posed unique challenges to the CEI firm. First of all, our contract was held with Link, which was the developer, not with the Port Authority. However, based on the documentation, the RPW, or the requirements and provisions of work, the CEI firm reported to Link, which was the owner, or Link was the developer, and it reported to the Port Authority. So we had dual lines of reporting, but we got paid by one entity. Also, the Port Authority of New York and New Jersey had the ability to assess monetary damages or points against the CEI for any work that was not done, or any of our work was not done in accordance with our contract or our requirements. We also had weekly meetings with the Port Authority of New York and New Jersey, in which the developer sat in to go over schedule of future work, to go over past challenges, and to really assure that we were following what the Port Authority's intent was for this project. So this was unique for me in the fact that we had almost two owners, or two bosses. Now, as you can imagine, over the 5 years of this project, the CEI had many roles and responsibilities. As you can see them listed here, the obvious ones are obviously we had to ensure that the project was built in accordance with the plans and the specs, but we had a luminous volume called the RPW, which was everybody's Bible, and that stands for Requirements and Provisions of Work. We were also responsible for oversight of the lead contractor's quality control plan. We had to make sure that the contractor was doing, documenting, and verifying what the plans and specifications said. We had controlled inspection checklists, which I'll mention a little bit later. We had a witness and hold point program, which in essence meant that the contractor can do certain activities, and some of them had to be checked by the CEI, and some of them they could move on without our oversight. Obviously, there's certification of results, the NCRs, or the non-conformance reporting, quality assurance documentation. It was a very documentation-oriented project. Daily work reports, construction certificates, and punch lists. So just to be clear, the CEI had not a unique role in the industry, but a unique role for what you would consider resident engineering services, because we had no schedule responsibility and we had limited payment invoice responsibilities and change order responsibilities. So we were truly a quality assurance arm of this project. And as you can see by this definition, our job was to provide confidence to the Port Authority of New York and New Jersey that the work that was done and the work that was paid for by the developer was done in accordance with the plans and specifications and quality requirements that were on the project. What you see before you is a 900-page quality assurance plan that was put together, developed, and drafted by the CEI firm, by KS Engineers. This document, along with the lead contractor, KWM's quality control plan, made up what was known on the project as the quality management plan, which was the responsibility of the developer. And again, it included the lead contractor's quality control plan, and it included the CEI's quality assurance plan. Now, contained within this plan, and I know you can't see this because this is very small, was just some of the tasks that we had to perform on the Goethals Bridge project as part of our scope of work. And some of the things that may not be normal on a project were surveys. We were responsible at times for underwater surveys, and we were responsible for spot checking the contractor's survey. In addition, we had crane responsibilities, and Rasul could possibly go into some detail, but every single crane that came on the project, we had to review the documentation and send it to the Port Authority's crane department, I believe it was, for final approval. Equipment calibration, something that people don't think of. All material and testing of equipment, or equipment that we or our subconsultants used on the project, had to be calibrated, and that calibration record had to be kept up to date. We were audited on that on a monthly basis by the Port Authority. In addition, like I mentioned before, we had to do non-conforming reports, or reports that would show when things did not comply with the plans and the specs. Going along with that, we had to help the contractor develop recovery plans for frequently occurring NCRs, or non-conforming items. In addition, there was certification and training. We had to certify that the people that we had on our project had the proper certifications, training, ACI, ASTM, or whatever qualifications were necessary. Here you can see the organization chart, and as I mentioned before, you see that the CEI firm, with circled on the right, KS Engineers, reported directly to the developer, as did the lead contractor and the lead engineering firm, Parsons Transportation Group. And all of us reported directly to the Port Authority. Now, the owner's representative for the Port Authority was HNTB, and they had on-site and in-house inspectors throughout the project. They did audits, they did field audits, they did our quality assurance audits. So they really were the eyes and the ears of the Port Authority in New York and New Jersey. With any successful project like the Goethals Bridge, you're only as successful as the staff and as of the partners that you have on the project. And KS Engineers was fortunate to have some exceptional sub-consultants. We had GPI providing us geotech and structural inspectors. EPM was our environmental arm. HRV did off-site inspections for us. HVEA, Key Tech, and AEL did materials and on-site inspection. I mentioned our underwater survey that was handled by AIA. New York Geomatics was another one of our survey firms, and KPFF provided our stay cable expertise and our stay cable staffing. They were another key sub-consultant or subcontractor for KSE on this project. Here you can see our staffing plan. At the height of the project, KS Engineers had 35 multidiscipline staffing people, ranging from office engineers, structural inspectors, geotech inspectors. We had electrical, mechanical, environmental, mostly civil and structural inspectors, in addition to our cable stay inspectors. What we're most proud of, or one of the things that KSE is most proud of, is the diversity of the staff. We had staff members from every walks of life, including women. As a matter of fact, at one time on the project, our coding inspector, our office engineer, our stay cable inspector, and our electrical inspector were all women. So you can see that we really did have a diverse staff, and it really helped in implementing and ensuring a successful project. Also, some of the things that the staff did that probably normal for most construction projects, we had, in addition to the contractors' daily safety meetings, we had weekly safety meetings with all the staff to talk about pertinent safety items. We also had weekly senior staff meetings that covered other items besides safety. And we had monthly training sessions with all staff to train them on proper use of equipment, of how to fill out forms, DWRs, or any of the pertinent topics that we needed to go over for that period. Just a couple of the just a couple of the details of the project to get you a feel of what you're going to be looking at in the next couple of slides. The replacement bridge had 6 12-foot lanes with full shoulders, as opposed to the previous 2 lanes in each direction at 10 feet. It was a state-of-the-art cable stay design Obviously, there were updated security and safety features. It provided pedestrian and bicycle access, and also it would accommodate future mass transit between the two structures. There's innovative bridge technology that Rasul is going to discuss in a later slide. The bridge parameters, as you can see here, I mentioned that it had to span a 500-foot navigation channel, but the main span was 900 feet, as you can see. The back span's approximately 370 feet, and the flanking spans 190 feet apiece. The slide that I'm about to show you is an overall time-lapse photography movie that was put together by the Port Authority of New York and New Jersey. There, I believe, was 3 cameras throughout the project that took photos and videos in real time, but it was delayed by a day, I believe, on the Port Authority's website. So what I'm about to show you here is a time-lapse video of the entire construction of the Goethals Bridge Replacement Project.